Hello students, in today's session we are going to see solving non-homogeneous linear equations by rank method part 2 and the same steps. So yesterday class we have seen how to apply the rank method for the given linear equations and the steps are here. So let me recall that. First step, write the matrix equation Ax equal to B. Second step, write the augmented matrix AB, that is the joint matrix of A and B. And step 3, after writing the AB matrix, we have to bring echelon form in AB matrix by using elementary transformations. Step 4, after bringing the echelon form in AB matrix, we have to find the rank of A and rank of A comma B. I hope you all know that how to find rank of A and rank of A comma B. And with this, we have to verify the type of solution for the given equation. The first type we are going to verify, step number 5, if rank of A is equal to rank of A comma B and equal to n, if all the three are equal, then the system is consistent and has unique solution. Okay, so now step 6, if rank of A is equal to rank of A comma B, so these two values are equal, rank of A value and rank of A comma B value, but that is less than the number of both or less than the number of unknowns, then the system is consistent and has infinitely many solutions. Keep this point, this step in mind, because today we are going to see only these type of sums. And step 7, if rank of A is not equal to rank of A comma B, then the system is inconsistent and has no solution. So in today's session, in most of the sums, we are going to have this type, consistent and has infinitely many solution, and inconsistent and has no solution type. So keep in mind step number 6 and step number 7. So before starting the session, so I want to give you one hint, and that is this: solve x plus y equal to 5. I have given only one equation and I am asking you to solve. Is it possible to solve this equation x plus y is equal to 5? No. The reason is, here we have only one equation, but in the equation you can see we have two variables. So whenever the number of equations are given, first see how many variables are present in it. So here the number of variables is 2. So keep in mind the number of equations is 1. So actually the number of equations and the number of variables must be equal. If the count is equal, then only you can solve. So here we have one equation but two variables. So the number of equations is less than the number of variables. So you cannot solve the given sum. So what we are going to do to solve in other words, you can see, to solve any system of equation, the number of variables must be equal to the number of equations, right? Okay, then how to solve this type x plus y equal to 5? That's a simple process. Here we are going to equalize the number of variables with the number of equations. So I'm going to reduce one variable. So by doing this one, so we have to eliminate any one variable in the given equation by assigning arbitrary constant. Arbitrary constant means any constant. So that thing I'm going to take it as k, and instead of y I'm going to apply in the given equation. So instead of y I'm going to assign an arbitrary constant k. So let y equal to k. If you take this and apply in the equation, you will get x plus k equal to 5. So which gives x is equal to 5 minus k. So now we got the x value. What is the x value? 5 minus k. And what is the y value? K. Now together we can write the solution. The solution is x comma y is equal to 5 minus k comma k. So this k is a real number. It can be any constant. So first I am going to apply 0. So when I apply 0, I will get 5 minus 0, 5, and in k's place if I apply 0, I get 0. When I apply k equal to 1, I get 5 minus 1, 4, and in the k place when I apply 1, I get 1. So the solution is 4 comma 1. So like that I can apply a lot of values for k, because k is any constant. So you can apply any real number. So how many real numbers you can apply? You can apply infinitely many real numbers. So when you apply the numbers in this solution set, you will be getting infinitely many solution. So this is the reason why we get consistent, and has infinitely many solution. So now we are going to see the sums. Example number 1.10. Show that the equations 2x plus y equal to 5 and 4x plus 2y equal to 10 are consistent and solve them. Okay, let's go for the sum. And here the given equations first I'm writing. You can see 2x plus y equal to 5 and 4x plus 2y equal to 10. What is the first step? We have to write the matrix equation. So I have written the matrix equation. So you can see ax equal to b, that we got. And now the second step is we have to write the augmented matrix. So augmented matrix is a b matrix, the joint matrix of a and b. So we are writing the joint matrix of a and b. So 2 1 5 and 4 2 10 I have written, and between a and b I am drawing a line. Okay, but now we have to bring the echelon form, that is step 3. So I'm going to do it. And here the first row first number is not 1, so but no problem for this sum. So here the second row first entry we have to make it 0. So I can see the second row first entry is 4. How can I make the 4 entry as 0? I can take this transformation. R2 implies R2 minus 2R1. So what is R2 entry? 4, 2, 10. And 2R1 means multiply 2 in the first row. So 2 into 2, 2. 2 into 1, 2. 2 into 5, 10. So while subtracting we get 0, 0, 0. So this time the last row fully we got 0, and we got echelon form also. You can see the red color arrow mark thing, and this matrix is the last equivalent matrix. Hereafter you cannot reduce this matrix to any other form by using transformations. So this is the last equivalent matrix which is in echelon form. So after finding the echelon form, what we have to do? After bringing the echelon form, we have to find the rank of A and rank of A comma B. So you know how to find the rank of A. So hide this last column in this last equivalent matrix, so you get A matrix. So in this we can see only one row having non-zero entries, therefore rank of A is 1. And now how are we going to find this rank of A comma B? So now you just include the B matrix with the A. So now we get fully AB matrix. In this we have only one row with non-zero entries. So therefore rank of A comma B is also 1. And n is nothing but number of variables. So how many variables they are using? They are using x and y. So 2 variables. So n is equal to 2. So rank of A and rank of A comma B, they are both 1. So they are both equal, but that 1 is less than 2. So that's why here we write rank of A is equal to rank of A comma B, but less than n. So therefore you can say the system is consistent and has infinitely many solutions. I hope you understand. I repeat again, here the rank of A and rank of A comma B values are same. So we put equal to, but that values are lesser than the n value. N is 2, so it is less than that. So rank of A equal to rank of A comma B is less than n. So it is a condition for consistent and has infinitely many solution. So now we are supposed to find the infinitely many solutions general form. So what we have to do, as usual, we have to go to the last equivalent matrix. You can see the red color arrowed matrix, and that you take and copy from the last equivalent matrix. AB matrix is 2 1 5 0 0 0, and you can see the black color arrow mark up. That means by back substitution method we have to write the equation. The last row is fully 0, so I cannot make any equation, so I can use only the first row. So the first row is what? 2 1 5. When I construct it as an equation, I get 2x plus y equal to 5. Is it right? Okay, so here we have only one equation but two variables. Is it possible to solve? No. So that only I told you the hint when I started the session. So here you see the number of variables are 2, the number of equation is 1. So we have to make it equal. So eliminate any one variable. So the choice is yours. You can put either x equal to k or y equal to k. So here I am going to apply y equal to k. When I apply y equal to k, I get 2x plus k equal to 5. So 2x equal to 5 minus k. So x equal to 5 minus k by 2. Therefore the solution is x comma y equal to, x value is 5 minus k by 2 comma y value is taken already k, so k, therefore the k value belongs to r. So you can apply a lot of values for k because k belongs to r, so you get infinitely many solutions. So example 1.13, and here also the same. Show that the equations are consistent and solve them. They have given three equations. So let's enter into the sum. Okay, so the given equations I have written here, and from that I'm writing the matrix equation. The first equation coefficients are 1 1 1, the second equation coefficients are 1 2 3, the third equation coefficients are 1 4 and 7. And x matrix, the variable matrix, this time we are having three variables, so x, y, z, and equal to the constant matrix. We have entries 6 14 30, so that also written. So we got ax equal to b. Now step 2 is we have to write the augmented matrix, that is the join matrix of AB. So I'm going to join A and B matrix, and that is written. You can see A and B matrix is written, and after between A and B I am drawing a line to isolate what is A elements and what is B elements, right? And AB matrix is we got. And now what we have to do, we have to bring the echelon form. So bringing echelon form means the second row first number and third row first place and second place. These elements must be made as 0 using the transformations. So here it is very easy because in all the rows the first number is 1. So very easy to do. So I'm going to take the transformation. R2 implies R2 minus R1. So sideward you can see the calculation. So R2 entries are 1 2 3 14 and R1 entries are 1 1 1 6. So while subtracting we get 0 1 2 8. So this should be filled in the second row now. And next for R3 also, R3 first place we have to make it 0. So that is also easy this time. So R3 implies R3 minus R2. So the entries of R3 are 1 4 7 30, and entries of R1 are 1 1 1 6. Now sorry, R2 are 1 2 3 14. Now while subtracting we get 0 2 4 16, and that should be filled in the uh, third row now. And after that the second row and third row they both started with 0. Now the third row second place we have to make it 0, that is the twos place we have to make it 0. So the same place in second row we have 1, so we can make 1 as 2 easily by multiplying 2. So for this thing we have to take the transformation. R3 implies R3 minus 2R2. So R3 entries are 0 2 4 16, and R2 entries are 2 R2 entries are 0 2 4 16. So while subtracting you get fully 0, so that should be filled in the last row now. Here this in this matrix we got the echelon form. You can see the red color arrow mark I have made. So further you cannot solve this matrix by using any transformation. So this is the last equivalent matrix, it is in echelon form. Okay, after bringing the echelon form, what we have to do? We have to find the rank of the A matrix and rank of AB matrix. So now we are going to find the rank of A. So take the last equivalent matrix and hide the last column. So now you can see A matrix. In this A matrix, the red color arrow matrix, you can see in that I have hidden B. Now you can see only A matrix. In this we have two rows with non-zero numbers. So therefore rank of A is 2. So how will you find rank of AB? Include the B matrix now. Okay, in this one you can see again in only two rows we have non-zero numbers, therefore rank of A comma B is also 2. Okay, how many number of unknowns now? So x y z, so n is equal to 3. Okay, right, so this time also you can see rank of A and rank of A comma B, they are equal to 2, but it is less than the n value 3. So rank of A is equal to rank of A comma B but less than n. Therefore the system is consistent and has infinitely many solutions. Okay, we have to find the many solutions value. Okay, the general form. So take the last equivalent matrix, the red color matrix, write that AB equal to 1 1 6 and 0 1 0 1 2 8 and 0 0 0 0. Okay, so I have given a yellow color arrow mark. That means by back substitution method you have to frame the equations. The last row is fully 0, so we cannot frame any equation. but the second row we can frame equation. So in the second row the x coefficient is 0, so leave it, but for y we have 1 and for z we have 2, so y plus 2z is equal to 8. And the first row we can make it as an equation 1116 means x plus y plus z equal to 6. Okay, so this time we got two equations, but in that you can see they are using three variables. So number of equations is 2 and number of variables is 3, so they are not equal, right? So we have to make it equal. So you can reduce any one variable, so either x or y or z, but this time you reduce z or y, so that is highly preferable. So put z is equal to k. So when I put z is equal to k in the first equation, when you apply, that is y plus 2z equal to 8. In that equation you put z equal to k, so you get y plus 2k equal to 8. So y equal to 8 minus 2k, right? And then now the second equation you take and apply the values. So x plus, for y we have to substitute 8 minus 2k, and for z we have to apply k. So when you solve this, keep x value one side and other values to the other side, so you get x equal to k minus 2. Therefore the values of x, y and z are obtained. So with this we can write the solution set. The solution is x comma y comma z is equal to x value is k minus 2, y value is 8 minus 2k, and z value is k. So here also the k value belongs to r. So that means you can apply infinitely many values for k, that gives you infinitely many solutions. So now exercise number 1.1, sum number 4 we are going to see. Show that the equations, they have given three equations, are consistent and solve them by rank method. So we are going to use the rank method to solve the given equations. First I have written the given equations. The matrix equation I am writing. First equation coefficients 5, 3, 7. Second equation coefficients 3, 26, 2. And third equation coefficients 7, 2, 10. And the variables we are using are x, y, z. So that is our x matrix, and equal to the constant side you can see 4, 9 and 5. So we got ax equal to b. Now with this we have to construct the augmented matrix. So what is augmented? A and B join matrix. So I am going to join A and B matrix. I have got the A and B matrix, and in between A and B a line is drawn to understand they are different. Now this time in the first row, first number, we are not having 1, so it's not a problem. So if you have 1, the sum calculation you can do it easily, that's all. So here we are having 5. The second row first place, and the third row first place and second place we have to make it 0 to get echelon form. So we are going to have this transformation. So R2 implies 5 R2. Why I am going to do 5 R2? When I multiply 5 in the second row, so 3 becomes 15. So like that, minus 3 R1. So when I multiply 3 in the first row, the 5 becomes 15. So both will be equal. Then when we subtract we get 0. That's why. So R2 implies 5 R2 minus 3 R1. So 5 R2, you can see the calculations nearby. 5 R2, so multiply 5 in the second row fully. 5 into 3 15, 5 into 26 130, 5 into 2 10, 5 into 9 45. Then 3 R1, so multiply 3 in the R1 row. So 5 into 3 15, 3 3s are 9, 7 3s are 21, and 4 3s are 12. And in the transformation we have 5 R2 minus 3 R1. So give the minus sign in 3 R1 row and subtract it. So you get 0, 121, minus 11 and 33. And this is the second row. Now fill it in the second row. And now we are going to do for the third row, first place we have to make it 0. Third row first place is 7. First row's first place is 5. So do one thing, take 5 and multiply in the third row, and take this 7 and multiply in the first row, so that the values will be equal. So we can subtract and make it 0. So R3 implies 5 R3 minus 7 R1. So 5 R3 means 5 into 7 35, 5 2s are 10, 5 10s are 50, 5 is 25. And 7 R1 means multiply 7 in the first row. So 7 5s are 35, 7 3s are 21, 7 7s are 49, and 7 4s are 28. And give the minus sign and subtract. So you're getting 0, minus 11, 1 and minus 3. Take it and fill it in the third row. So we got this for second row and third row starting with entries 0. So now in the third row, the second place we have to make it 0. Before that, I can see the second row 0, 121, minus 11, 33. It is fully multiples of 11. So I can divide the second row by 11. So R2 implies R2 by 11. So when I divide 121 by 11, I get 11. Minus 11 by 11 means minus 1. And 33 by 11 means 3. So it gets reduced to this form. So hereafter it is very easy. The second row, third row, the second place we can make it easily 0. So the third row, second place is minus 11. In the same place, in the second row we have 11. So simply add both rows. That's all. So R3 implies R3 plus R2. So what is R3 entries? 0, minus 11, 1, minus 3. R2 entries are 0, 11, minus 1, 3. When you add, you get all the 0 values. So take it and fill the third row. So now we got the last equivalent matrix. Hereafter you cannot apply any transformation. So this is the last equivalent matrix. So we got it. So the last equivalent matrix is in echelon form. So after finding the last equivalent matrix, what we have to do? We have to find the rank of A and rank of A comma B. So I'm going to find rank of A. So this, here you can see I have hidden the B matrix. So now the rank of A is 2. The reason is in A matrix we have only 2 non-zero entries. Two rows are having non-zero entries. And now include the B matrix with that. So now in the AB matrix you can see in 2 rows we have non-zero entries. Therefore rank of AB is also 2. And n is nothing but the number of variables. So we are using 3 variables x, y, z. So n equal to 3. So here you can see the rank of A and rank of A comma B are equal. They are both 2. But the number of unknowns is 3. So rank of A is equal to rank of A comma B, but it is less than, both are less than n value. Therefore the system is consistent and has infinitely many solutions. Okay, how will you find the infinitely many solutions? General form. So you have to take the last equivalent matrix. So the last equivalent matrix is 5, 3, 7, 4, 0, 11, minus 1, 3 and 0, 0, 0, 0. That is the echelon form matrix I have copied here. You can see the last equivalent matrix, right? And after this, by using the back substitution method, we have to create the equation. You can see the last row is fully 0, so we cannot make any equation. But the second row we have coefficients. What are they? 0, that is no x term. We have coefficient for y 11 and minus 1 is for z. So 11y minus z equal to 3. So you got it, 11y minus z equal to 3. And the first row you have 5, 3, 7, 4. So 5x plus 3y plus 7z equal to 4. We got two equations. Here also you can see we have two equations but 3 unknowns. So we have to reduce any one unknown. So assign z is equal to k. Then only the number of equations and number of variables will be equal, right? So apply z is equal to k. Now take z equal to k and apply in the first equation. So 11y minus k equal to 3. Take this minus k to the other side. So you get 3 plus k equal to 11y. So from that, if you want to find y, take 11 to the other side. So k plus 3 by 11. 3 plus k and k plus 3 both are same. So I write it as k plus 3 by 11. Now use the z value k and y value k plus 3 by 11 in the equation 5x plus 3y plus 7 is equal to 4. So in this I am going to apply the values. When I apply and simplify, I get x equal to 7 minus 16k by 11. So this answer I am getting. After that I have to write the solution. The solution is x comma y comma z is equal to 7 minus 16k by 11 comma y value k plus 3 by 11 comma z value k, where k belongs to R. So this k belongs to R, all must write. It's a very important point. So for this we have 1 mark in board exam. For the last step, if you forgot to mention this k belongs to R, the mark will. So now example number 1.14. The given equations are x minus 4y plus 7z equal to 14 and 3x plus 8y minus 2z equal to 13 and 7x minus 8y plus 26z equal to 5. Okay, the three equations we got it. So now the matrix equation we have to write. So the coefficients of the first matrix is, first equation is 1 minus 4 7, and second equation is 3 8 minus 2, and third equation is 7 minus 8 26, and the variables used are x y z, and the constants on the right side are 14 13 and 5. So here Ax equal to B matrix we got the first step. Second step we have to write the augmented matrix. So join A and B matrix. So we got the augmented matrix AB here, you can see. So now we have to bring the echelon form. So second row first place, and third row first place and second place we have to make it 0. And here as usual, so R2 implies R2 minus 3R1, because we have 3, the first place we have 3, so R2 minus 3R1. So R2 is entries are 3 8 minus 2 13, and 3R1 means 3 into the first row, so 3 into 1 3, 3 into minus 4 minus 12, 3 into 7 21, and 3 into 14 42, and subtract it, so you get the answer 0 20 minus 23 and minus 29. So take that and fill it in the second row. Now we have to focus in the third row. The third row first place we have to make it 0. So we have 7 in that place. So this time the transformation R3 is R3 minus 7R1. So what is R3? 7 minus 3 26 5. 7R1 means multiply 7 in the first row. 7 into 1 7, 7 into minus 4 minus 28, 7 into 7 49, 7 into 14 is 98. And now subtract them, so I getting the entries 0 20 minus 23 and minus 93. Okay, so this time the second row and third row they started with 0, you can see. So we have to do the transformation only between R2 and R3, and you can see the third row second place is 20, and the same place in second row is also 20. So it is very easy. So you can do the next transformation. R3 implies R3 minus R2. So R3 entries are 0 20 minus 23 minus 93, and R2 entries are 0 20 minus 23 and minus 29. So the transformation is R3 minus R2. So in R2 row I am giving change of sign and I am solving that. So I get the answer 0 0 0 64. So that should be filled to the third row now. So this is our last equivalent matrix. So in this we got the echelon form, and hereafter we cannot do any transformation here. So that's why it is the last equivalent matrix. In this we can see the triangular form of zeros. So the last equivalent matrix is in echelon form. So now we have, so the last equivalent matrix is in echelon form. So now we have to find rank of A and rank of A comma B. So the last equivalent matrix, in this I am going to hide the B matrix now, you can see. So in this one A matrix we have 2 rows with non-zero entries, so therefore rank of A is 2. Now include the B matrix also. So now the rank of A comma B you are going to calculate. So in AB matrix you see we have all the 3 rows with non-zero entries. The last row the non-zero entry is minus 64. So therefore rank of A comma B is 3. So now A rank of A and rank of A comma B, they are not equal, they are different, right? So rank of A is not equal to rank of A comma B. Therefore the system is inconsistent and has no solution. And now example number 1.15. So find K if the equations x plus 2y minus 3z equal to minus 2, and 3x minus y minus 2z equal to 1, and 2x plus 3y minus 5z equal to k are consistent. This time you can see in the question clearly we have to find the value of k if the equations are consistent. That means they are saying clearly the equations are going to be consistent. In that case find k. That's the question. So now let's get into the sum. So here the equations I have written. So with that we are writing the matrix equation. First equation numbers 1 2 minus 3, and second equation numbers 3 minus 1 minus 2, and the third equation 2 3 minus 5, and the x, capital X is the variable matrix xyz, which is equal to the constant matrix minus 2 1k, that is B. And now we have to join A and B. So the augmented matrix AB is we got this AB matrix, and in between A and B we have to draw the line to identify A elements and B elements. And now we have to bring the echelon form. So I take the transformation for this one. So R2 implies R2 minus 3R1. So the entries of R2 are 3 minus 1 minus 2 and 1, and 3R1 means multiply 3 in the first row and right. So 3 into 1 3, 3 into 2 6, 3 into minus 3 minus 9, and 3 into minus 2 minus 6. And change of sign you have to give, because R2 minus 3R1, so change of sign. So when you apply this, you get the answer 0 minus 7 minus plus 7 and then 7. So take this and fill it in the second row now. And now we have to do it for the third row. Third row, first place also we have to make it 0. So for that the transformation is R3 implies R3 minus 2R1. So R3 entries are 2, 3, minus 5, K. This time it is not a number, it is K. And then 2R1 means multiply 2 in the first row and right. So 2 into 1 2, 2 into 2 4, 2 into minus 3 minus 6, and 2 into minus 2 minus 4. Then R3 minus 2R1. So change of sign we have to give in the second row 2R1. Now solve it. So we get 2 minus 2 0, 3 minus 4 minus 1, minus 5 plus 6 is 1, and this time we are not having number. This place you can see K plus 4 you have to get, right? K is a variable and 4 is a number, so K plus 4 you should write. So that to be filled in the last row now. Okay, but now still the third row second place is not 0, we have minus 1 in that. In the same place in the second row we have minus 7, so we can easily make the minus 1 as 7 minus 7 by multiplying 7 in that row fully. So I am going to take the transformation. R3 implies 7R3, this time R3 to be multiplied by 7, 7R3 minus R2. So the last row fully we have to multiply 7. So 0 into 7 0, and 0 into minus 1 into 7 minus 7, and 1 into 7 7, 7 into k 7k, plus 4 into 7 28. So 7k plus 28 we get. And now R2 entries are the same, 0 minus 7 7 7. So now change of sign, because 7 R3 minus R2, so we have to give the change of sign. So now subtract 0 minus 0 0, minus 7 plus 7 0, and 7 minus 7 0. So 7k you have to write the same, because there is no k terms, so 7k you have to write. So 28 minus 7 gives 21, so we get 7k plus 21. So now the third row will become 0 0 0, 7k plus 21. Now we have to find the k value for the given question. So the given question is, if the system is consistent, so that's the thing. So you can see the last equivalent matrix is in echelon form, right? So here the rank of A is 2. You can see only for the A matrix, if you observe, the rank of A is 2, because we have two non-zero rows, so rank of A is 2, right? Now since the system is consistent, because it is given in the question, the system is consistent, rank of A and rank of A comma B must be equal. So what is the value of rank of A? 2. So that must be rank of A comma B. If rank of A comma B is also 2, here you can see rank of A comma B equal to 2, that means the last row must be full and full 0. So last row must be full and full 0 means I have marked in the last equivalent matrix, red color, 7k plus 21. That place also must be 0. So take that place as 0. So 7k plus 21 equal to 0. That means 7k equal to minus 21. So k equal to minus 3. So this value, find k if the equations are inconsistent. Okay, we have to find the value of k in the case if the equations are inconsistent. So first we are writing the given equations, and with that the matrix equation is written. So from the first equation I write the coefficients 1 1 1, second equation coefficients 1 2 3, third equation we don't have x term, so 0, for y we have 1, for z we have k, so 0 1 k. And the variable matrix we have to write x y z, because three variables are used. And the constant matrix is 7 8 6, 7 18 6, that is B matrix. Now, second step, we have to write the augmented matrix. So join A and B matrix. So the A and B join matrix we obtained. So we have to bring the echelon form in this matrix, AB matrix. So what is echelon form? The second row first place and third row first and second place we have to make it 0. So already third row first place is 0. So it is enough to make the second row first place 0 now. So second row first place is 1. First row first place is also 1. So it is very easy. So the transformation is R2 implies R2 minus R1. So R2 entries are 1, 2, 3, 18, and R1 entries are 1, 1, 1, 7, and R2 minus R1. So give minus to the R1 row and subtract it. You get 0, 1, 2, 11. Take it and fill it in the second row now. So we got this, right? So we got this one. And now the second row, okay. Third row first place we got 0, but third row second place also we have to get 0. So in the straight to that, in the second row we have 1. So it is very easy to do that calculation. So R3 implies R3 minus R2. So R3 entries are 0, 1, K 6, and R2 entries are 0, 1, 2, 11. Now change of sign, because R3 minus R2, so change of sign you have to give it in R2 values. Now subtract it. 0 minus 0, 0, 1 minus 1, 0. K is a variable, 2 is a number, so you cannot subtract them. So but just write it in a equation form. So K minus 2, then 6 minus 11 becomes minus 5. Take it and write it in the last row. So we got it. Now we have to find the value of k if the system is inconsistent. Okay. Now if the system is inconsistent means then rank of A is not equal to rank of A comma B. So this case is possible only when this k minus 2 value becomes 0. That's why I have given a red mark there, red color arrow you can see. If that place is 0, just assume if that place is 0, rank of A will be 2, right? And rank of A comma B will be 3. So they will not be equal. So obviously the system will become inconsistent. That's why we are going to choose to make the system inconsistent that k minus 2 place must be equal to 0. So that means k is equal to 2. So and students, please practice all the sums whatever we have discussed today, and this is very important. And one more point, in exercise number 1.1 I have excluded two sums, sum number 2 and 6, and in examples also two sums are excluded. So these four sums are a bit lengthy and the calculation part is quite different, so that should be taught on board. That's why. And once the school reopens, so we will have the four sums. We will teach that four sums on the board, so don't worry about it. And practice whatever we have completed except that, so please practice it in a separate note, so then only it will be highly helpful for you. Thank you.